Okay, several things that we're going to look at here, some with domain and discontinuity, vertical asymptote holes, some of the same stuff we've already talked about, plus a little bit more. So first of all, let's identify our domain. All right, so again, if you take your denominator and set your denominator equal to 0, of course, to solve this, you are going to have to factor. And this will factor as x minus 6 times x plus 2. So you're going to get x equal positive 6 and x equal negative 2. Now, any value that causes your denominator to equal 0, you will have to leave those values out of your domain. Because remember, domain is going to be everything that it can be. So you would say that you have all real numbers except x equals 6 and the negative 2, okay? Now, that's also, remember, going to tell you about your points of discontinuity. Anything that has to be left out of the domain will also be points of discontinuity. So that would also be x equals 6 and the negative 2. Now, we're also going to talk about removable and non-removable that we did a while ago, but if you look back in your notes, you basically figure that out by the fact of the vertical asymptotes and the holes. So we need to next actually figure out vertical asymptotes and holes. Now, to do that, remember we start out by finding out what values make our denominator equal 0. And we've actually already done that. Okay, that's actually, from this step right here. We've already found out what makes our denominator equal 0. So let's take the x equals 6 and the x equal negative 2, and let's just figure out what's happening at each one of those. All right, so the difference in the vertical asymptote and the hole is whether it causes your numerator to equal 0. So if I were to substitute 6 into my numerator, that's actually going to give me 18 minus 18, which is 0. So that means that this is actually going to be a hole. Okay, then if I substitute negative 2, then that's just going to give me negative 24. So as long as it's making only the bottom equal 0, then it is just a vertical asymptote. Okay. So x equals 6 is the hole, x equal negative 2 is the vertical asymptote. Now, whether we identify it as removable or non-removable, and actually whenever you go to do your homework, at the same time it asks about points of discontinuity is when it'll ask about removable and non-removable. So since 6 is a hole, then based on your notes I told you that that would be a removable discontinuity. Excuse me. Okay, and now negative 2 is a vertical asymptote, so vertical asymptotes are always going to be non-removable. Okay, so 6 is removable, negative 2 would be considered non-removable. Now, I also want to talk about the intercepts. So finding the x and the y intercepts. So I told you to find an x-intercept that you're going to let y equal 0, but it's actually going to be just as simple as setting your numerator equal to 0. So if I take my numerator and set my numerator equal to 0 and I solve it, I'll have 3x is equal to 18 and I get x is equal to 6. Now here's where you've got to be careful because sometimes the number that you will get here will also be one of the same values that's not in your domain, or that's also a discontinuity. And see, that's what's happening with the 6. Now remember, we figured out that 6 is a hole. Well, remember, a hole is just a little open circle in your graph, so there's no way that that can actually be your x-intercept. So because this is a point of discontinuity, then what you would have to say is there's no x-intercept. Okay, now let's talk about a y-intercept. Now you find a y-intercept by letting x equal 0. So actually in your function, you're just going to substitute 0 into the problem. So you'd have 3 times 0 minus 18, and then 0 squared minus 4 times 0 minus 12. So I end up with negative 18 on the top, negative 12 on the bottom, and that's going to reduce to be a positive 3/2. So positive 3/2 would be considered your y-intercept.